பண்ற நீ திருப்பி கிளாஸ் ஆகுது
doing experiments. I'll be back in 2 minutes. So I'm sharing my screen. By the time I'm back, you start doing these problems. Do it in the order. I'll come and discuss. Yeah. So do the first one. What answer, guys? So what is the formula for self-inductance?
Sir, it is mu naught n square AL.
See, mu naught n square AL is the formula for self-inductance when you know the area of cross section, all those things. But here, if you see, you should always look at the given data. N is 1000, right? Current is 4 ampere, and magnetic flux is 4 into 10 power minus 3 Weber. So if you go and revisit, what is the basic formula of self-inductance? How did you get that mu naught n square A into L divided by mu naught n square A into L? Go and see the derivation of what is the first step that we used. Go check the derivation immediately. Mu naught n square A into L is right, but here you can't use it.
Sir, it is L equals N phi B by I.
Very good. That's the answer. So you have everything. No, N is there, phi is there, I is there. Substitute, that will give you the answer.
Okay, sir.
So 1000 into 4 into 10 power minus 3 divided by 4. 4 and 4 cancel. 1000 and 10 power 3 cancel. 1 Henry is the answer. Next. So there are two coils A and B. A current starts flowing in B if coil A is made to rotate about a vertical axis. No current flows in B if A is rest. The current in the coil A, when the current in B at T is equal to 0 is counterclockwise, and the coil is shown as instant T. Yes. So there are two coils A and B. Current starts flowing in coil B if coil A is made to rotate about a vertical axis. No current flows in B if A is also at rest. So till here, what are they trying to say? What law did they give us in a different language? Try to read it and understand the question. This is Faraday's law of EMI. Okay. So the current in coil A, when the current in B at T is equal to 0 is counterclockwise, and the coil A is as shown at the instant T is equal to 0. Okay. Now what are we supposed to do? We need to find the current in coil A. How to find the current in coil A? So current in coil B is in which direction? Guys, unless you are going to speak, even I will be silent only.
It's
Not open.
counterclockwise.
Okay. So what pole will get generated?
North pole.
Very good. So it is North pole, correct?
Yes, sir.
So when it is North pole, this is revolving, right? So initially at T is equal to 0, the coil A would have been at rest.
Yes, sir.
But at the instant it was put into revolution, can I say that, see, initially before T is equal to 0, both of them would have been at rest. For T less than 0, both of them are at rest. So the current in B is 0. Now, as soon as the coil A is put into revolution, you are able to see a current in it. Means in the coil B, is the flux increasing or decreasing at T is equal to 0? At T is equal to 0, in B, is the flux increasing or decreasing?
Increasing, sir.
Yes, it is increasing. Means what should have happened? It is increasing means what should have happened? This should act like North Pole. Right? Yes. So when this is going to act like North Pole, they're asking what is going to be the current in this coil at that instant.
Sir, should it be constant current counterclockwise? Option A.
Which option A. But thing is, the coil is put into such a revolution. Wait. when you see from the top, the coil will rotate in the clockwise direction. When the coil is rotating in clockwise direction, the magnetic dipole moment will be at the bottom. This will be north and south. Let me think. Yes, that's right. Constant current counterclockwise.
Yes, sir.
Right. So next one is simple. You can solve it. Do it fast and tell me. When a current changes from +2 to -2 ampere in 0.05 seconds, an EMF of 8 volt is induced in the coil. The coefficient of self-induction is L is equal to, what is the formula? E divided by delta I divided by delta T. So E is 8, delta I is 4 divided by delta T is 1 by 20. So it is 160 by 4.
40.
40 is not there. No, option itself is not there.
So is that in minutes? No.
Oh, no, I made a mistake. 4 divided by 0.05. So this will go 2 times. Sorry.
Sir, 8 will go 2 times.
I think there is a mistake. So 2 into, no, correct only. 2 into 0.05. That will give us 0.
So 0.1.
So option B is right. This one you need not do. Growth and decay is not there in your syllabus. Similarly, fifth one, try it out. WB stands for Weber here. Okay, don't get confused. So there is a square of side L meters lies in the XY plane in the region where the magnetic field is given by B is equal to B naught into 2I cap plus 3J cap plus 4K cap plus the magnitude of the flux through the square is. So there is a square which is lying in XY plane. The aerial vector of this coil will be in which direction? So area as a vector will be L square. If a coil is lying in XY plane, okay, what is the direction of aerial vector? Aerial vector is perpendicular to the coil. So A vector will be L square K cap, right? When it is L square K cap, when you multiply both as a dot product, okay, flux is equal to B vector dot A vector, you will get 4 into B naught into L square. So option is A. Okay. Sixth one, try it out. In a car spark coil, an EMF of 40,000 volt is induced in the secondary when the primary current changes from 4 ampere to 0 in 10 picoseconds. Find the mutual inductance between the primary and the secondary windings of the spark coil. So EMF is 40,000 volt. Primary current changes from 4 ampere to 0 ampere in time 10 picoseconds, 10 into 10 power minus 12 seconds. Find the mutual inductance between the primary and the secondary coil. So M21 or something like this is equal to E divided by delta I by delta T. Same formula. That is 40,000 divided by delta I is 4 divided by 10 into 10 power minus 12. So this will go 1000 times. So 10 power minus, so 10 power 3 into 10 power minus 11. How much is the answer?
10 power minus 8.
So 10 power minus 8 Henry is the answer. Seven. An electric current flowing through a wire in the direction from B to A is decreasing. Find out the direction of induced current in the metallic loop kept near the wire as shown. So, due to this current carrying conductor, what is the direction of magnetic field inside the circle? Is it into the plane or out of the plane?
Sir, can you repeat it?
Due to this current carrying conductor, what is the direction of what is the direction of magnetic field inside the, or if I take a point P here. So what is the magnetic field at point P due to this current carrying conductor? Use right hand thumb rule and tell no.
Outside the plane.
They use right hand thumb. You guys wrote a test also, no? Yes. Fourth chapter, writers, due to this coil is not there. If this is not there, what would have been the direction of magnetic field near that point?
Into the plane.
It is into the plane, no? When it is into the plane, they told current here is decreasing. When current is decreasing, magnetic field will decrease. So when magnetic field is decreasing, flux will decrease. So when flux is decreasing, what pole will get generated? Opposite pole, no? So since here it is into the plane, this acts like south pole. So what will be the opposite pole here?
North.
North pole.
North. So what will be the answer? The current will be in the anti-clockwise direction. Okay. So this problem not needed. This is not needed. Try the 10th one. Calculate the mutual inductance between two coils when the current of 2 ampere changes to 6 ampere in 2 seconds and induces a 20 millivolt in the secondary coil. Twenty into 10 power minus 3 divided by 4 by 2. It will be 2. So 10 into 10 power minus 3, it will be 10 power minus 2 Henry.
Sir, the same formula you used in the previous one, sir.
It's the same type of question, no?
Okay, sir.
There is only formula. So for 11th one, this is where you need to be careful. If current changes through circuit, eddy currents are induced in the nearby ion plates. Is it right or wrong? If there is a change of current taking place, then eddy currents are induced in the nearby ion plates. It is true. Due to the change in current, the magnetic flux through the iron plate changes. Is it true? Yes, it is true.
True.
So both are true. Is the reason right explanation for A?
No.
Yes, it is. Because eddy currents are getting generated only due to the change of magnetic flux through the iron plate.
Okay. Okay.
Okay.
Yes. Understood.
Yeah. Next. An EMF E is induced in a closed loop where magnetic flux is varied. The induced EMF is not a conservative field. An EMF is induced in a closed loop where magnetic flux is varied. So it is true. Okay. The line integral of E dot dl around a closed loop is non-zero. So what does the line integral of E dot dl tell us, guys? Let us see how much you remember this concept. So how much is this? This is a slightly tricky question only. We know that E is equal to minus dV by dl. So dV will be equal to minus E dl. So integrating on both the sides, you get integral of E dl is equal to V. So what are they trying to say? The line integral of E dot dl around a closed loop is not equal to 0 because EMF will get induced. Right. So reason is assertion is true and the reason is true and both support each other.
Option A, sir.
Yes. Thirteenth, assertion. The bar magnet falling vertically along the axis of the horizontal coil will have an acceleration less than g. True.
So that G is gravitational acceleration, no, sir?
Yeah, acceleration due to gravity. Yes. So what will happen is when this is falling, right, there will be an increase of flux taking place. When increase of flux is taking place, there will be a north pole that will get generated. Due to the north pole, there will be an anti-clockwise current that is getting induced in it.
Sir, R is false.
Right. So due to which this is true. Clockwise current is induced in the coil. That is false. So A is
False.
true. R is false. That's it. 14th. This is the problem which I told you. Exercise 7.5. So example 7.5, I think, yes. A coil of self-inductance L is connected in series with a bulb and an AC source. The brightness of the bulb decreases when? Anybody who can tell me the answer. I told you at that point it is important also.
Sir, is it because of option A, frequency of the AC source is decreased?
No. The answer is an iron rod because when you increase the frequency, listen, when frequency is increased, XL will increase. Sorry, frequency is decreased. When frequency is decreased, XL will decrease. When XL is decreasing, I will increase. So when I is increasing, what will happen?
The bulb will glow brighter.
Yes. Whereas when an iron rod is inserted, mu will increase. When mu is increasing, L will increase. When L is increasing, XL will increase and I will decrease. Hence, this is the right option. Whereas, if you increase the number of turns, then L will increase. When L is increasing, XL will increase and
So that is given number of turns is reduced.
reduced. Sorry, if it is increased, then it will be right. The number of turns are reduced. N will decrease, then L will decrease, XL will decrease, and I will increase. So bulb will glow brighter. This is not possible at all because there is no capacitance. Okay. Now try the 15th one. In an LCR series AC circuit, the voltage across each of the components LC and R is 50 volt. The voltage across the LC combination will be.
Is it 100?
Why 100?
Sir, each of them have a 50 volt. No, sir. So
VR, VL, VC. So voltage across VL and VC put together will be how much?
0. Okay, sir.
That's yes. But they both are always out of phase.
Okay, sir.
So in an AC circuit containing only capacitor, the current leads the voltage by 90 degrees, remains in phase with voltage, leads the voltage by 180, lags the voltage by 90. At least this you should be able to answer first. (17) The primary winding of a transformer has 50 turns and secondary has 500 turns. The primary is connected to an AC supply of 20 volt to 50 hertz, 20 volt and 50 hertz. Then the secondary will have. So E1 by E2 is equal to N1 divided by N2. What is the value of E1? 20 divided by E2 is equal to N1 is 50, N2 is 500. Cancel 10 times. So E2 will be 200. So 200 volt and the same 50 hertz. It is a step up transformer. So the power factor varies between 0 to 1 because cos phi is equal to, yes, cos phi is equal to R by Z and cos lies between -1 to 1, but power factor won't be negative, so it will be between 0 to 1. So plot the graph showing the variation of capacitive reactance versus frequency. It will be a decreasing graph. Next, the time constant of the RC circuit not needed. So this is not from this chapter. 22. An inductor coil joined to a 6-volt battery draws a steady current of 12 ampere. The coil is connected in series to a capacitor and AC source of alternating EMF 6 volt. The current in the circuit is in phase with EMF. Find the value of RMS current. Not needed. Okay. Which device will use to step up AC voltage? Can we use the same device to step up DC? Yes. What is the answer?
Sir, I'm not sure.
What is the answer? Which device will use to step up the AC voltage? Transformer. Can we use the same device to set up DC voltage? Not set up, it is step up. Answer is, I told you while I explained this. No. Because you need change in flux. Right. Now what about 24? So there is a capacitor of suitable capacitance can be used in a circuit in the place of a choke coil. Okay, this choke coil and all are not there for you. Cancel it. Voltage magnifier, cancel it. 26th right. What is the answer, guys? At least check your book and tell me. And here you guys torturing me. At least try, no. You open your textbook, the answer will be there. At least try the assertion. It's like I feel like as if I'm solving this paper for myself.
Option B.
Option D, 2 or 4? Option 2 or 4?
Option 2.
How did you say? We use thick wire in the secondary the step down transformer to reduce the production of heat. That's right. Right. When the plane of the armature is parallel to the lines of force of magnetic field, the magnitude of the induced EMF is maximum. That is also true. So both are true.
Magnetic fluxes also increase.
Yes, but they are not the right reason. The reason is not the right explanation for assertion. 27. At resonance, the inductive reactance is equal and opposite to the capacitive reactance. True. In series LCR circuit, the inductive reactance is equal to the. In a series LCR, the inductive reactance is equal and opposite to the capacitive reactance. False. Because reactance doesn't have any direction. So A is true, but R is false. 28. When capacitive reactance is smaller than the inductive reactance in series LCR circuit, voltage leads the current. True or false? It is true, because if capacitor is dominating, then we know for a capacitor the current will voltage leads the current. When a capacitive reactance is smaller than, okay, that's right. So when a capacitive reactance XC is less than XL, then it becomes more like an inductive circuit. In an inductive circuit, the voltage leads the current. Yes, it is true. Similarly, in an in series LCR circuit, inductive reactance is always greater than the capacitive reactance. False. Need not be. So A is true, but R is false. Okay. So I'll do just 2 more problems. After that, I'm giving the sheet to you guys. You guys solve them. Okay. See, this is something similar. This you can do it as homework. This textbook problem. This textbook problem. We'll try 32 and 33. How much current is drawn by the primary of a transformer which steps down 220 to 222 volt to operate a device with an impedance of 220 ohm? So if you guys remember this, I1 by I2 will be equal to E2 by E1 is equal to N2 by N1, which implies I1 by I2 how much current is drawn by the primary? I1 is how much, which steps down 220 to 22. So I1 by I2 will be equal to 220 divided by 22. It will get cancelled 10 times. Sorry. 22 by 220. 1 by 10. So I1 is equal to I2 divided by 10. But what is the value of I2? I2 will be equal to 22 divided by 220 again. So that will be 1 by 10. So I1 will be equal to 1 by 10 into 1 by 10. It will become 1 by 100. It will be 0.01 ampere. Okay. So 33rd. Last problem for the day. I can't book. My head is paining. A circuit containing a 20 ohm resistor and 0.1 microfarad capacitor in series is connected to 230 volt AC. What are the and the angular frequency is given? You guys tell me how to do this problem. What is the impedance? So Z is equal to root of R square plus XC square. So root of R square is 400 plus XC is 2 pi F into C the whole square. Oh, they have already given omega itself. No, omega C the whole square. 2 pi F is 100. So 100 into C is 0.1 into 10 power minus 6 the whole square. Okay, solve this, you will get the answer. That's it, I'm done. Did you copy it?
Yes, sir.
That's it, guys. Is there any other doubt you have? Okay, we wind up.
Thank you.
Thank you, sir.
Thank you, sir.